Okay, cool. We just spent some time discussing the laws of exponents that will help you to simplify expressions and maybe even equations that involve exponential terms or factors. So we're now going to take an example that involves just multiplication and division. The approach that you use when you work with questions that involve multiplication and division is different from the approach that you will engage if we had pluses and minuses in our expression. So in this current expression, we only have to take a particular factor, multiply it with something else, and then divide with something times something different. So when you've got an example such as this one, how do you approach that question? Okay, cool. So the first thing that you need to understand is laws of exponents only work when you're multiplying same bases. Something needs to be the same, or maybe same exponent. So I've got the first example here that says 7 times a to the power of 4 times b to the power of 3. Maybe that's something else we also need to discuss in terms of what you're looking at here. Even though there are no multiplication signs between the 7 and the a, there is a hidden times sign. In addition, between a to the 4 and a b to the 3, there's also another multiplication that is not appearing, but it's there. You need to know that as mathematicians, we're very lazy. So instead of writing a multiplied by b, we sometimes write that as ab because we think everyone who is doing math knows that there is a multiplication sign in the middle, even if it's not written. Okay, cool. Now, when you're multiplying these things, you're going to multiply the corresponding characters. Don't even rush yourself. Take your time and identify who is the same as who and put them side by side. It's not necessary, but I'm going to do that for this first example since this is our first example in this context. So 7 is friends with minus 3. So I'm going to put them side by side. I'm going to say 7 multiplied by negative 3 and put those ones in a small group. Then I'm going to go and identify a to the 4 and its friend. It happens that we have got a to the 4 and we also have a squared there. So I'm going to put those ones again next to each other. So I have a to the power of 4 multiplied by a to the power of 2. This is not necessary, by the way. I'm only doing it to show you what is going to happen. The b's can also be combined together. I'm going to have b to the power of 3, which is b cubed, multiplied that by b to the power of 5. This is just good practice to help you to understand what I'm going to do when I simplify here. Similarly, on the denominator, we've got 6.5, which can be put as 6 times 1 over 2. I've got a cubed and a cubed, which can be written as a to the power of 3 times a to the power of 3. And then I don't have a b here, but I've got that b to the power of 6, which I can put as b to the power of 6 as a loner. Right. Now, once I'm done with this, we're then going to simplify by doing 7 multiplied by 3, which gives you negative 21, times your a to the 4 and a to the 2 is to, remember, when you're multiplying same bases, the first law says we need to add the exponent. So a to the power 4 and a to the power 2 is going to be a to the power 4 plus 2, which is going to give you 6. So I'm going to have a to the power of 6 times the b to the 3 and the b to the 5. Again, when you're multiplying same bases, you're going to add the exponent. So this is going to give me b to the power of exactly 8. Divided by, on the denominator, half of 6 or 6 times half is 3. I'm going to have a 3 there. There's a to the 3 and a to the 3. When you're multiplying same bases, you add the exponents. I'm going to have a to the power 6, and that b has been a loner. It's going to come back as b to the power 6. You'll notice I'm not putting any multiplications in the middle because I know mathematicians know there's a multiplier that is there even though it's not written. Now, once I'm done with that, I'm then going to say, okay, let's find what we can do with this. You'll notice that your 21 divided by 3 can be divided. You're dividing corresponding characters, the same ones that match. So this is a number, this is a number. When you divide them, you're going to get exactly negative 7. And then when you do a to the power of 6 divided by a to the power of 6, according to our laws of exponents, when you're dividing same bases, you subtract the exponent. So I'm going to do 6 minus 6, which is going to give me a to the power of 0. And then for the b's, I've got b to the 8 and b to the 6. When you're dividing same bases, you must do top exponent minus bottom exponent. This is going to give us b to the power 8 minus 6, which gives us a value of exactly 2. Now, can I do more on this? Yes, it turns out we can do more on this. Given that a is not 0, or we're going to make an assumption that a is not 0. If a is not 0, then a to the power of 0 is going to give us a value of 1. So this is just as good as negative 7 multiplied by 1 multiplied by b squared. And when you multiply minus 7 and 1, you're going to get minus 7b to the power of 2. And that should be the solution to the first question. So now I'm going to go quicker on the second one because we've got an idea of what to do here. This one, I've seen here that we've got a lot of multiple bases on inside my bracket, and I've got an exponent outside. So we've got a law that says how do you raise a power to a power, and that law says we can actually distribute that exponent and give it to each one of those bases that we have inside there. So this is going to be 3 squared, which I'm going to write as 3 to the power of 2, right? Multiplied by p cubed with a square again. That's going to be p cubed with a square, and then that's going to be q squared there. That's my q to the power of 2. So I'm distributing that outside exponent and giving it to all the bases that I have inside my bracket. Now here I've got a problem. I've got a fraction there which I don't like. So I'm going to do the following. Remember, when you're given 1 over q squared, you can express it in exponential form and rewrite it as q to the power of, you're just moving it from denominator back to the numerator, right? And the exponent is going to change sign from being plus 2 to being minus 2, and then I still have on the outside that minus 3. Everything needs to be divided by. Once more on the denominator, I'm going to share the 4, give it to 2, share the 4, give it to p, as well as q to the power of 3. So I'll have 2 to the power of 4 times p to the power of 4 times q to the power of 3. That must also get its own exponent 4, right? Okay, now in conclusion, let's fix by removing the brackets. When you remove the brackets, we always remove brackets by multiplication, right? So I'm going to multiply these ones to clean them up. Remember, when you've got a power raised to another exponent, you can just multiply those exponents. I'll get 3 squared times p to the power of 3 times 2, which is going to give us p to the power of 6. Q squared comes back. There's my q squared. My q to the power negative times negative is positive. 2 times 3 is going to give you exactly 6. Everything must be divided by 2 to the power 4, which I'm writing here. P, which I'm going to keep there as p to the 4. And here we multiply once more. Brackets mean multiply. So 3 times 4 is going to give us a value of q to the power of exactly 12. Right. So I'm done with that. I'm now going to simplify further by checking what is happening on my numerator, or maybe let's put it here. So 3 squared is actually 9. Divided by 2 to the power 4 is 16. Right, times the base p. We're actually trying to figure out the solution, so that's going to be top exponent minus bottom exponent. That's going to give you p to the power of 6 minus 4, which is going to give you 2. And then times, this one is 2 and 6. When you're multiplying same basis, you're going to have to add the exponents. So when I add 2 and 6, I'm going to get 8. But that 8 must be divided with this q to the power of 12, so we're going to then need to subtract. So I'm going to have 8 that I'm getting when I'm adding, and then minus the 12 that you have in the denominator. So it's going to give me q to the power of exactly negative 4. That's my final exponent. But we don't like leaving our answers with negative exponents. So what I'm going to do is, whenever I have a negative exponent, I'm just going to take it back to the fact that we agreed that q to the power negative 4 can be written as 1 over q to the power of positive 4, which is making it a fraction, because it's actually the same thing. So my final answer is going to be, on the numerator, I'll have 9. And then I'm going to have p squared right there, divided. And then on the denominator, I've always had 16, so I'm still going to have 16. But that q to the power of negative 4 is also going to go on the denominator, and I'll have q to the power of 4 as my final answer there of this particular expression.